for over half a century. The promise of clean, limitless energy from nuclear fusion has felt like a mirage, always shimmering on the horizon, always 30 years away. It became a running joke, a symbol of a future that never quite arrives. But what if I told you that joke is getting old and the punchline is about to change? What if the fusion dream is finally waking up to become our reality? Stick around because the game has fundamentally changed. For decades, the biggest hurdle wasn't just physics. It was belief. Governments and investors poured money into massive, slow-moving international projects like ITER in France. These are incredible feats of engineering, no doubt designed to prove fusion is scientifically possible on a grand scale. But they are also slow, bureaucratic, and incredibly expensive. Their timelines stretched for decades, reinforcing that 30 years away narrative. We got stuck in a loop. Fusion is expensive and slow, so it only gets funded for slow, expensive projects, which proves it's slow and expensive. It was a self-fulfilling prophecy, but in the last decade, something new started bubbling up. A new generation of scientists and engineers, many of whom grew up on the sidelines of these mega projects, started asking a different question. Instead of how do we build the biggest, most perfect machine, they asked, how do we build a smaller, faster, and commercially viable one? This shift in mindset opened the floodgates. Private companies started popping up, backed by venture capital from people like Jeff Bezos and Bill Gates. Suddenly, it wasn't just a science experiment anymore, it was a race. This new wave is fueled by incredible technological breakthroughs. Let's talk about magnets. The traditional way to contain a spar in a jar, which is basically what a fusion reactor is, involves massive, powerful electromagnets. But now we have high-temperature superconducting magnets. These things are a total game changer. They are vastly more powerful and efficient than their predecessors. What does that mean? It means you can achieve the same magnetic field strength with a much smaller device. A reactor that once needed to be the size of a sports stadium could now, theoretically, fit inside a large garage. This miniaturization drastically cuts down on construction, time, and cost, making fusion a much more attractive business proposition. Then there's the power of modern computing. The plasma inside a fusion reactor is an unbelievably complex, chaotic beast. In the past, trying to understand and control, it was like trying to predict the weather a year in advance with a pocket calculator. We can test new designs, predict plasma behavior, and optimize reactor performance in virtual space before a single piece of metal is ever cut. Companies like Google's DeepMind have even used AI to sculpt and control the plasma with unprecedented precision. A task that was once thought to be impossibly complex for humans alone. This computational power is accelerating the design-build-test cycle at a dizzying pace. Let's look at some of the key players in this new fusion race. You have companies like Commonwealth Fusion Systems, a spin-off from MIT. They're using those powerful new superconducting magnets to build a compact, high-power reactor called Spark. They've already proven their magnet technology works, a huge milestone that sent shockwaves through the industry. Instead of a continuous burn like a star, they're creating and smashing together balls of plasma in rapid pulses. A method they believe will be simpler and more direct to convert into electricity. Another one, General Fusion, has a wild idea involving a sphere of liquid metal, pistons, and shockwaves to compress the plasma to fusion conditions. The point isn't that one of these will definitely win. The point is that, for the first time, we have dozens of different approaches being pursued in parallel, all competing, all innovating. This is the Silicon Valley model applied to fusion energy. It's fast, it's agile, and it's not afraid to fail and try again. This diversity of ideas is our best bet for finding the one that finally cracks the code for commercial fusion. So, when can we expect to plug our phones into a fusion-powered grid? Well, let's be realistic. We're not flipping the switch tomorrow. The scientific challenges are still immense. We need to sustain the fusion reaction long enough to produce a net energy gain, a milestone known as ignition. We need to figure out how to efficiently extract that energy as heat and convert it into electricity. And we need to develop materials that can withstand the intense heat and neutron bombardment inside the reactor for years on end. These are not trivial problems, but the timelines are no longer measured in multiple decades. Many of these private companies are aiming to demonstrate net energy gain within the next few years. They're targeting the early 2030s for their first pilot power plants. That's not 30 years away. That's around 1 decade. And once one company proves commercial viability, the investment and development will explode. It will be like the dawn of the aviation age or the Internet revolution. Imagine a world powered by fusion, a world with zero carbon emissions, a world where energy is abundant, cheap, and available to everyone, everywhere. No more geopolitical conflicts over oil, no more fears about climate change. It would elevate humanity in ways we can barely even comprehend. This is the prize we're fighting for. The 30 years away curse was never really about the physics. It was about our approach, our ambition, and our belief. For the first time in a long time, all three of those things are pointing in the right direction. We're seeing a convergence of new technology, new money, and a new can-do mindset. The fusion race has begun, and this time the finish line is finally in sight. It's no longer a distant dream. It's the next great technological leap for humanity, and it's happening right now. Thanks for watching. If you're as excited about the future of energy as I am, make sure to like, subscribe, and hit that notification bell so you don't miss our next video. See you in the future.